I think my job is quite special. I mean, for once, it's put me in front of you on this really great stage, but there's more to it than that also. Because I work in R&D, a really kind of research part of R&D. We're building a web development platform, and that means that it's my job to understand what are all the things that are difficult in building web applications. What are the things we can make better? What are things that just have to be difficult because the world is difficult and complicated? So one of the things that is very difficult that I'm now starting to understand, and I'm sharing my understanding here with you today, is about building full stack things that update in real time. So you got many different real-time update use cases. Some examples, kind of, if you do some background job, you're waiting for it, you want to show a progress indicator to your user. Maybe you got some live updating charts or kind of monitoring what goes on in something. Then we got a bunch of more collaboration related things, just seeing in real time who else is active in the application right now. Locking things to kind of avoid accidental conflicts. Notifications when something happened, delivered in real time, of course. Chatting with other people working on the same thing. Editing things together. So all of these are examples of real-time updated things. And around 10 years ago, we got this amazing technology called WebSocket. Or 10 years ago was when it was kind of adopted well enough that people could actually use it. And the thing is, I've come to realize WebSockets, they're a great foundation. But if you just start with, okay, I've got a WebSocket, how do I make this thing update in real time? Then you end up building lots and lots of abstraction and complexity and so on that just gets in the way. You will probably want to add an event bus and some automatic subscribing and unsubscribing and so on, and it just gets more and more complicated because the world is complicated. But what I've realized, and kind of, it's taken me these 10 years actually, because I have on and off been thinking about this specific problem, and I've come up with all these solutions. Yeah, let's add an event bus and so on, but it never really felt right until just last year when I got this kind of flash of insight. And based on that, everything is so simple. So if you only remember one thing from what I'm going to be talking about, then you should remember that the key trick, in my opinion, to do real-time updating in a really simple way is to think of it as shared UI state. Because you got these users, they work together, and some part of that UI state is shared between them. So if you have this mindset, this way of looking at things, then not only will it get kind of easier to deal with it, you will still write lots of code, of course, because you're a developer, but it will be easier to think about it, easier to kind of reason about how things should go, who notifies what, and so on. And that's really a powerful simplification. But that's enough about me for now. What about you? I've got this little poll to find out about what you are doing. So should we make it? No, you can see it well around. So you can scan this with your QR code reader, or you can also just go to, oops, somebody redeployed the application. One moment. Nope. There we go again. Sorry about that. So v-herd.eu/poll, or then just read the QR code, and let's wait till we got decent amount of numbers. You see that counting up in the lower right corner. So we're at 60. I would guess we need to get to, yeah. Well, okay, we ended at 60. 63. Okay, now it raises again. Yeah, okay, well, you can still find your way out in if you're late, but let's ask you then, how do you build your UIs? Let's make it a little bit bigger. So, what are the options? I mean, I'm biased. I work for Vaadin, so I put that at the top. Then we got the 3 most popular single-page application frameworks. We got React, we got Angular, and we got Vue. Then the world is full of other client-side rendering solutions. The biggest one is known as jQuery. Anyone use that? But there's also, of course, lots of other things there. Then server-side HTML, we got Leif, we got PHP if you're a really old-timer, JSF, JSP, all these kinds of things. We got desktop or native mobile. So, I mean, if you're a React native user, check React and native mobile because you're doing both. And then, of course, somebody just doesn't do any regular UIs at all, so there's an option for them as well here. See, we got around, yeah, most people have answered, and yeah, it seems quite as expected. React and Angular are very popular. A little bit of a kind of anecdote, but interesting detail. Here in Belgium, Angular is more popular than React, but in most other parts of the world, React is actually more popular, but for some reason, it's just different in different places. Okay, next question. Have you already built applications with real-time UIs? So some of you maybe do that all the time, and you already know all the pros and cons. Some of you maybe have tried it a little bit, want to do more maybe. Some not yet, but definitely planning to do it. And maybe not planning to do it, and in that case, maybe this isn't the talk for you, I don't know, but feel free to stay here. Let's wait till the numbers stabilize a little bit. Yeah, seems like the overall trend is that most of you have kind of tried it out, but it's not what you do day to day, so probably you might not have kind of realized all the pros and cons and challenges and so on, and then you have lots to learn from me. And even if you have lots of experience, maybe my perspective is new, so that's also a good thing to know. Final question. If you're not doing it all the time, then why not? So, I mean, maybe the kind of stuff you work on doesn't have any use cases that would benefit from real-time updates. Maybe it would benefit from it, but your customer or product manager or whatever just doesn't realize it. Maybe you're afraid of kind of, well, it will make the UI more complicated, we need to spend more time designing the UI and so on. Or maybe it's kind of, yeah, we're all in, but it's just so difficult to do it. So it seems we're again, well, quite even split. Most of you say it's not our use case. Some say, well, I would love to do this, but I'm not sure how to do it in a good way. And I mean, that's exactly what you're here. You're here to learn. So the plot twist here is what you're looking at now is a real-time updated application, because immediately when you vote, everyone else sees that same thing. So what we're going to do actually is look at how would you build this application, or how would I do it, because I'm supposed to be the expert here. So someone keeps playing around there. Someone is having fun. Let's just move on. That's about you. So I would say to build any real-time updated application, including this poll, there's 3 basic steps to it. First, there's the UI design, because you actually need to take real-time updates into account a little bit, not too much. But then what I'm suggesting is, then you continue with a really kind of simple, stupid solution, not thinking about real-time updates at all, just building it as though there wouldn't be any other users, no updates from the server, nothing. Just keep it really simple. And then, thanks to this mindset of sharing the UI state and building a little bit of library around that, then it's really easy to then go and just make it real time in almost no time. So that's what we're going to look at here. Starting with the UI design. This is what I got from a great UI designer. So this isn't a UI design conference. I will not go into much details here. 2 things I will mention. One is you actually need to take real-time updating into account. Because otherwise, if you just take kind of something not taking it into account and add real-time updates to it, then probably you will confuse the users. Because if things just start changing without any reason, then that's just confusing. The other thing is more of a technicality. When you have real-time updating things, and you of course care about accessibility, users using screen readers and so on, then you also on a low level kind of HTML level design, you need to think about how your updates are notified to the screen reader. So there's a whole bunch of techniques there that also out of scope here, but just mentioning that, have a look at those if you need them. The next step after UI design is to identify, kind of start making this interactive, but still keeping it real simple. So it's all about identifying what are all the moving pieces. What's the state? Because I kind of gave it away. We want to share some of that state with other users. So we need to identify those. So in our real simple UI design, the most obvious thing is the vote count. So one number for each of the different options. There's more state here though. One thing is the state of each of these toggles. So, because I mean, optimally, I was too lazy to implement it that way, but optimally, you would implement it so that when the user reloads the page, it would remember what you had selected so that you can't kind of easily give multiple votes. Of course, software is software, you can always work around it, but at least avoid the kind of very simple mistakes. Next thing though, as you noticed, I could just from my mobile phone click through my secret admin UI, click through to change which question is shown. So that's also something that is dynamic. That's also in one way or another, that's UI state. And finally, related to that also, depending on how it's implemented, the current options that are available to choose from, that might also be seen as UI state. Or then you implement it so that each of the different questions is kind of a hard-coded set of options, and you switch to different views or different templates or something. But it might also be that you have a data structure with the names of the options and kind of what colors and logos they should have and so on. But point being, all of these things, they're updated, or they might need to be updated, and that's why we kind of need to treat them as UI state. So with that background, let's actually take this UI that you got from the designer and make it come alive, but still not real time. So if we close this, here we got, on the left-hand side, I got a really awesome UI designer. He even gave me working React code with all the things needed. And on the right hand, we see how it actually renders. So, I mean, if you have seen any React or basically any HTML-based, component-based thing before, it's kind of nothing special. Just noting, we got here the class name. If we remove that, then my real-time live reload isn't working. Okay, now it works. So then it's really ugly, but if we add it back, then we get the nice looks and so on here. What we really got? Well, there's the heading. There's, for each of the options, there's another vertical layout, so that's just a flex box with some defaults. Checkbox inside that for making the selection and lots of CSS around that. And then a div with the number and then a little bit of inline CSS to adjust the size of it. So what we want to do is we want to introduce state variables. I'm going to make it simple only for the counts. Let's not deal with changing to a different question and so on. So what we need is basically 3 different holders of state. We're going to put those in an object so we can also use the labels from there. So we got options here, and that's an object. We got a VAD in option. And there we're going to have kind of what's the value there. I'm using something called signals for state management. Might be familiar, maybe not. But for now, all you need to know is that a signal is something that holds a single state value. We got React, and let's pick the default value from the UI design there. So 2 votes there, and then we got Angular with signal with one vote. And then what we need to do is, of course, we need to replace this vertical layout or these hard-coded layouts with actually a loop around it. So let's copy this, and then we're gonna do we need to iterate over both the keys and the values here. So we're gonna do the object dot entries of, no, not that thing, but of the options. And there we're gonna map over them. We're gonna receive a tuple with the label and the signal there. And then what we're gonna do in the callback is we're gonna return something like this. One thing we need to do, of course, because I'm using React, and React gets unhappy if you don't have a key there. So let's put a key there. Let's just use the label because those are unique enough. So if we save this, yes, HMR is not always perfect, but now we have lots of options here, but they're all the same. Let's remove this. And now we got just 3 of the options. So let's go on and put these values where they need to go. We should update the class name. That's also the same as the label. We should update the checkbox label. That's the text we actually see. And then here for the value, we should actually take that straight out of the signal. Yes, so let's save. And now we got the names, we got the styling right, but we haven't yet messed with the CSS to make the widths all right. And in this case, the width of each of the options is based on the max width of all of them. So let's create a computed signal for that. So const max votes is a computed signal. We're going to look at what these computed signals and so on are in a while. But here we need to get all the values. So that's just object dot, not keys but values of the options, and then those are the signals, so we need to unpack those. So map over and take the signal and just do signal dot value, and that's the votes. And then we're just going to find the max one, so return math dot max exploding in the votes and then throwing in a 1, so we never divide by 0. Then with that done, we're ready to update this final piece here. So we don't always do 100%, but we do 100 times the signal value divided by the max votes value, like this. And now with this update, it's actually the static data renders as we expect again. Next thing we want to do is to actually make it so that when I click any of these, something happens. So on the checkbox, we can just add an on checked changed, and there we get an event, and we're going to do something with it. We're going to do if event dot detail dot value. That's whether it's checked or not. If it's checked, then we do signal dot value plus plus. And if it's not checked, then it was previously checked, so then we do the opposite and reduce the number. So with this update, now if I check this one, well, then the max value changes, so the others gets thinner. If I check this one, then it gets thicker. So it seems like this works as we would want it to do. Okay, let's get back to the theory here. So what we saw here, kind of background for getting to the full stack signals, but regular signals, they are value holders and they are reactive, meaning that others can react when the value changes. Basic usage, you create a signal, give it an initial value, and that's your kind of holder of a value, in this case just the number 5. Then you can create computed signals. In this case, very simple, just taking the value of the count signal, multiply that by 2, so it's the double value. Then, to make things actually kind of come alive, interact with the rest of the world, we need to do an effect. An effect in this case means that it's kind of a side effect, not just a pure functional world anymore, but a side effect. What our side effect does is that it logs the value of the doubled signal. Immediately when we run this, it will log 10 because the effect is immediately active. And the real magic with signals is immediately when we increment the value, I mean count.value plus plus, it's just reading that 5 to say it's 6 and then writing that 6 back into the signal, then immediately that logs 12. And that's quite magic. The way it works is that when you create that effect, it runs that callback, and at the same time it detects which signals are read while running this callback. So in that way, the effect gets registered a dependency on the doubled signal. And the double signal is actually, it's lazy evaluated, so it's only, that callback is only run when the effect is run. That one is also run with kind of tracking dependencies. That one reads the count signal, so it gets a dependency on that one. And then when we change the value in that count signal, what happens is that it's invalidated, and all its dependencies are invalidated, which means that, well, then the computer's, the double signal is also invalidated. And when that's invalidated, then the effect is invalidated, and then we start over from the beginning again. So in this way, the magic of signals is that it automatically tracks dependencies on a very granular level. Because if I would have an if inside the effect, for instance, so in different cases it reads different signal values, then it would only, the effect would only be dependent on that specific value that I depended on the previous time it was run, whereas all the other dependencies are unregistered when it's invalidated due to some change. So with signals, you got 5 basic operations. You create a signal. I did that with the signal function. Or if you're inside a React component, you use the hook version, use signal instead. I read it with just reading the .value property, write it with assigning the .value property, computed function to create a derived signal, and then an effect function with a callback to listen to changes to whatever signals you have. This might look familiar to you, or maybe not. All the big 3 front-end frameworks and lots of the smaller ones also, they have signal support. In Angular, it's slightly different syntax. You read the value by calling the function, calling signal as a function. You set the value by calling a set method. React doesn't actually have signals, but there's this Preact library that integrates very nicely with React to give signals there also. And in Vue, it's almost the same. The name is just, it's a ref, not a signal, but otherwise almost the same. Well, the watch effect instead of effect also, but as you see, it's exactly the same concepts. It's just different, slightly different syntaxes there. Then we were ready to make this real time. And there's just one problem. And that problem is latency. Because that leads to conflicts. So again, taking a simple counterexample, if you at the same time, you start with the value being 0, and if we somehow share the value of this signal between many users, because of the network latencies, they don't immediately know about each other. So if at the same time 2 different users do signal.value plus plus, what we expect to happen is that, well, 2 increments have happened, so we go from 0 to 1 to 2. But what actually might happen due to the latencies is that, well, the first one runs, sees a 0, increments it to 1, and assigns that 1 back as the signal value. But at the same time, before that has actually happened, the other client also reads a 0, adds 1 to it, and assigns that, hey, now the value is 1. So this wasn't what we expected, but this is what we might, or we will eventually get. Maybe not when testing locally, but when we go to production, we will see it, and that's not fun. The way to deal with this is to not just synchronize the values, but instead synchronize the operations on the signal. So if we instead have a signal that has kind of an add operation, then we've got 2 different users at the same time doing add 1. Each of them can kind of on their own compute that, well, then the value would be 1 after being 0, but they're not sending an update over the network to the other users that, hey, now the value is 1. They send, I did an addition by 1. Because then, when these changes are distributed, everyone will receive first one addition and then another addition by 1, which means that they will actually end up with 2 as the value, and that's what we expected. So that's really great. So far, I have only shown very, very simple signals, very simple UI state. It's only numbers. And with numbers, there's kind of these arithmetic operations, it's what causes conflicts. With different data types, like if you got a list of things, the standard way of updating a list with like React or Angular or Vue is that you create a new list which contains all the old items and then that new additional one extra item that you wanted to add. And this will again cause conflicts because then you create a whole new list and you replace it with the previous one. And if two users do that at the same time, then one of the users' changes will be overwritten by the following one, and that's not good. So it means that you kind of, as you need more and more operations on different data types, you end up adding kind of insert last, insert first, insert between these two other items, remove, and all these kind of granular operations on that data, because otherwise you would have conflicts. Now we know enough to make this real time and really make that happen in almost no time. Here I've cheated a little bit since I have built or updated our UI framework to support this. You can of course also do this on your own because I mean it's a little bit of bookkeeping, but you need to do it only once, and when you have done it, then you can reuse the same concept throughout your whole application or throughout your whole older applications even. So to synchronize values, we need to have a server. And the approach I suggest is that actually always synchronize these values through the server, because you can do kind of peer-to-peer updates, but that's not really reliable and quite complicated and so on. But if you actually synchronize through a server, then you can also, for instance, you can get consistent ordering, which is very important if you have a locking use case. You don't want to have it so that suddenly you receive a new message, something that said that they tried to lock earlier, but because of network latencies, it didn't go through, and then what happens now when two users believe they have the lock and so on. So what we're going to do with our framework, as the example, I'm going to create a new Java class. Let's call it vote service.java. And what we do here is add a couple of annotations. We got browser callable annotation to make it actually available services or kind of methods from this service available to the server, to the client. And then we're going to add anonymous allowed just so that we don't need to have any access control check here. And then we need to basically have server-side signals for these things that we want to track. I don't want to hard code these, so I actually create a map with them. Let's create that as a just instance field. So map, that kind of map, yes, from a string to a number signal, which is again a type that we have built, and that's the options, and that's just a new concurrent hash map because we want to maybe create multiple of them at the same time. And then we just do a public method returning a number signal by a name, like so. And what we do here, I'll also release it, just get from options compute if absent, so create the first time. Name is the key, we get something we don't care about here, and then we just get oh, that's the arrow in Java, new number signal, and this is by default starts at 0, so we have a redundant null there. There we go. So this is all we need here. And again, with with my framework, maybe your framework is different, but with my framework, this also generates TypeScript to immediately access this. So if we go back to the demo, now here, first thing we need to do, in my case, is to move this out of the render function so it's not run every single time re-rendering, but instead just running it once to set up the subscription to the server-side values. So here we do vote service dot get and pass in Vaadin as the key, and then we just repeat the same for the other options and React and Angular. Well, it doesn't mind the typo because it just needs to be a unique key. So if we save this and see what happens, well, now we start from 0 because that's the value we had on the server. We can still vote, that's a good thing. But the cool thing is we got another client here also. Need to refresh that one also. So now, immediately when one of the clients puts in a vote, it updates their own local signal value, and that signal value update, or actually we forgot to do one thing. We forgot to actually not overwrite the value, but instead do an operation here. For some reason it's called increment by in our case, so increment by 1, and a little bit weird, but increment by -1. So now we're actually even thread safe, no conflicts, anything. We can just have all of you voting at the same time and it still counts everything right. And yes, it still works as expected even with this change. So those were the kind of key concepts of how you, when you think about it as shared UI state, you build your UI logic with just regular local state management, and then you just choose which pieces of that UI state do I want to share with other users. In our case, well, it was all of the UI state, but in more complex cases, usually it's not all of it. But just by having this granular state as signals in Angular, in React, in Vue, you can very easily, on a kind of conceptual level, make any of them real-time just by changing that it's backed by this signal that is synced with the server instead of being a local signal. I will now take any questions, if there are, before we wrap up and go to the next sessions. Anyone has any questions? Don't be shy. Did I really explain everything so clearly, or did you all lose track? No questions. Yep. Oh, there I see one hand. Okay, yep. Yes. Share something about the implementation of the backend. Any specific thing? What's behind it? So I mean, so far this is on a beta stage. So far it's just an in-memory value. We want to first make it to be instead an in-memory event log, because that also allows to do incremental updates. So if a client has been offline for a short while, maybe just lost network connection, then they can resynchronize, just get what are the changes to this signal since the last time I was online. Then also we want to be able to take this event log and distribute it across a cluster. So push it through a Hazelcast or a Kafka or whatever clustering technology you might be using to actually have it so that even if you have multiple front-end servers, then they still all see the same signal values. Did that answer the question? All right. Any other questions? Don't be shy. I just don't see you, but there we have a question. Yes? Yep. It's not a Lambda function. What it sends is it's a JSON object saying, now we're doing an increment by operation with these parameters. And then, I mean, one problematic thing for us Java developers is that we don't run JavaScript on the server. which means that, yes, I had to implement 2 times how to interpret increment by operations. Every single operation needs to be implemented both in JavaScript in the browser and Java on the server. But that's, again, it's a one-time investment. Then you can use the same kind of processing engine for all the different signal cases you have. All right, more questions. It's really difficult to see, but just shout if you got a question. I see one hand raised there again. Yep. So race conditions on the server side. Right now, when we have the simple implementation, we just do locking. It's very easy. When we receive an operation, we lock the kind of Java in-memory structure so that nobody else updates it at the same time. And then once we have updated it, we send out updates to all the currently active clients. And then we release the lock, which means that everyone will see the updates in the same order. Once we get to the event log, we need to actually do kind of append only event log, which kind of it's the same as with event sourcing, basically just always append things to the end of the log, and as long as the log itself is thread safe, then you are covered. All right, more questions? I don't see any raised hands. Scream if you still have something to ask. Going once, going twice, and sold. So, to wrap up, when you build a poll or anything else with real-time updates, there's, I would say, 3 very simple steps, at least when you build a simple demo. Start with the UI design. I mean, this is kind of like a waterfall, and we all know how good waterfalls are in software development. You start with the UI design, then you do a basic implementation without thinking about real-time updates at all. Just add your state management with your favorite front-end framework, and that's it. And then finally, when that's done, then you just go in and say, well, this piece of UI state should be shared, this shouldn't, and also kind of what's the scope of sharing it. So, I mean, I gave each of those signals a value that is then all other users using the same name for the signal will receive the same updates. So again, I don't know how many times I've said it, I'm saying it again. Think of real-time updates as shared UI state and all your problems will be gone. Thank you.
All systems are nominal. Initialize Genesis sequence.